Hi guys, welcome to my channel. So today we'll be discussing about the resistors which are connected in parallel, right? So in our last class we have discussed about the resistors which are connected in series, and in today's video we'll be discussing about the resistors which are connected in parallel. So once the parallel comes in mind, this is how it looks, right? The parallel lines and the resistors connected to it. So this is how the arrangement of the resistors look, correct, which are in parallel. And now once again drawing up the circuit, ammeter, battery, right? So this is how it looks more of less often. Now I call it as R1, R2 and R3. So three resistors which are connected in parallel. But whereas in series we could see the current I was similar, correct, was constant. But whereas here you could see the current is splitting up, correct, and then it is getting united. Now since it is splitted up, I'll name it as I1, I2, I3, and once again it is coming back to I, right? So this is how it more or less often looks. Now for this we are connecting a voltage to check the voltage, the voltmeter, the voltmeter. Now if you look at the circuit, you should come to know the voltage is constant, right? Throughout the circuit the voltage is constant, but whereas I is changing. So I is nothing but I1 plus I2 plus I3, but whereas voltage V1 is equals to V2 is equals to V3, and this is equals to V. Easy. Whereas in series I was constant, voltage was changing, whereas in parallel voltage is constant and current is what changing. Now I think by this time you should know what we are doing. So last time in series we have taken voltage into consideration and we derived the equation, but this time what is changing is current, so we need to consider current. And now applying Ohm's law. Okay, so now what we need to do, we need to apply Ohm's law. Now let's do it. Now applying Ohm's law, we know V is equals to IR. So I is equals to I1 plus I2 plus I3. This is nothing but resultant or sum. So you can write it as sum yes or resultant current. Now this is nothing but V into R, resultant, or so V by R. Sorry guys. So this is V by R, correct? R resultant. I1 is nothing but V by R1 plus I2 is nothing but V by R2. I3 is nothing but V by R3. Since V is constant, so I can write it as 1 by R resultant is nothing but 1 by R1 plus 1 by R2 plus 1 by R3. So in case of parallel, 1 by R resistance is nothing but 1 by R1 plus 1 by R2 plus 1 by R3. So this is what happens when the resistors are connected in parallel. So the resistance in series it gets summed up, but whereas in parallel this is how you need to represent. Easy. So hope I made this very simple. So what you need to do, you need to just remember the key points. Parallel, voltage is constant. Series, current is constant. This is how you need to remember, and you can just simply apply the Ohm's law and you can derive the equations for that. Okay, simple. So this is about the resistors which are connected in parallel. Hope you like this video. Okay, so if you please if you like this video, please make sure just like it and subscribe to my channel if you're a new viewer, and make sure you leave a comment. Okay, thank you so much. Stay tuned.